So if we want to graph tan, well, we should derive how this is going to occur. So let's review the unit circle again, because I like to have a clear understanding of where these values are coming from. Well, that's a good circle. And let's look at our quadrantal angles. Right, we're looking at points here, 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 and here. And this would be 1, 0, and 0, 1, negative 1, 0, and 0, negative 1. And we also made the statement that each coordinate represents the function value. So we would have cosine theta, sine theta would be our x and our y coordinates. So in that case, just to review this, right, sine of 0 degrees is 0. Cosine of 0 degrees is 1. Right? Cosine of 180 degrees is negative 1. Right? It's my x value is my cosine, and my y value is sine. And that's how, if you remember, we were able to derive the sine curve, right? We said sine of 0 is 0, sine of 90 degrees is 1, sine of 180 is 0, sine of 270 is negative 1, and sine of 360. Right? We went around looking at all the sine values, and we could do the same thing with the cosine values, right? And that's how we would get the cosine curve. And our cosine curve would look like this, because it would go from 1, 0, negative 1, 0, 1. 1, 0, negative 1, 0, and 1. But our tan of theta is equal to sine theta over cosine theta. That's an important identity. So then if we look at these values, I'll bring it up here so I have it on the screen. Right, if I look at 0 degrees, let's go in degrees, or no, let's not, let's do radians. So 0 pi over 2 pi 3/2 pi and 2 pi. Right? Now, if we're looking at our tan, y equals tan x, which would be our sine value over our cosine value. So tan of theta is equal to my y over my x. Right? So at 0 degrees, it's going to be 0 over 1. At 90 degrees, it's going to be 1 over 0. My y over my x. My y over my x. So this is going to be 0 over negative 1. And this is going to be my 3/2 is going to be negative 1 over 0. And 2 pi is 0 over 1. So let's simplify these. What do we have? We have 0 over 1, which is 0. 1 over 0, which is undefined. Then we have 0 again, and then we have undefined again, and then we have 0 again. There's going to be a tough graph to make with that information. So I want to look at a 2 pi interval, right? 1 revolution around the unit circle, and let's plot the points we have here. So 0, 0 is easy to do, right? That's 1 point. And 1/2 pi and undefined, well, that means we're going to have an asymptote here. And then I have pi and 0. And then I have 3/2 pi is an undefined. So I'm going to have another asymptote here. And then I have 2 pi and 0. Let me move this up. So I've only been able to really plot 3 points here. So maybe we should look for another point in between a point we found in this asymptote. Let's look at 1/4 pi. 1/4 pi. Where would 1/4 pi be on my unit circle? Right here. And what would be the coordinates of 1/4 pi? Well, it would be a 45-degree angle, right? We remember our special triangles, and we found some of these values like 30 degrees and 45 and 60. We found the coordinates here. I think this was rad 2 over 2, comma rad 2 over 2. That was my x and my y value. So therefore, I could say tan of 45 degrees is equal to my sine over my cosine. So tan, we don't want to write 45 degrees, we're going to write pi over 4, because we're using radian measure, is equal to my sine over my cosine. Well, my sine is rad 2 over 2, and my cosine is rad 2 over 2. So when I have a value divided by itself, that's equal to 1. So tan of 1/4 pi is equal to 1. So we have another point there. So it looks like this value is going to go up close to this asymptote, like that. In fact, we can continue doing this, but I just want to show you how these points are derived. But I'll show you what this graph is actually going to look like. This is going to come down to here, and then up close to this asymptote. And this is going to repeat. So that's what y equals tan x looks like. That's your tan graph. And that's how it's derived. We could find some more points in here. If you wanted to. We could derive them using our unit circle. Tan is always sine over cosine. Let's look at a clean piece of paper. Hold on a sec. So now every time you see y equals tan x, this is what you should be thinking of, right? And this continues on, just like with sine and cosine. We're just looking at the interval from 0 to 2 pi here, but this would continue infinitely in both directions. We're going to have these weird looking waves to the left of x, or rather to the left of 0 and to the right of 0, right? It would continue in both directions. Another thing that you want to note here is the period of tan, right? The period is the end of a complete cycle before it starts repeating. So when we look here, when does it start repeating? Well, if we say it starts here and goes up, and then it comes from here to here, and then it starts and goes up, well, then this is really one period. With tan, a period occurs at pi. So when we have to find the period, it'll always be pi over b, not 2 pi over b, right? Because sine and cosine start repeating after 2 pi, right? That's when we get repetition. That's not the case with tan. Tan starts repeating after pi, so the period is at pi. So to find pi is going to be pi over b. It's very tricky. So what if you were asked to graph y equals 2 tan x? Well, we want to find our amp, our period. I'd like to say the a and the b. And then we also always start by graphing a basic curve. So our basic curve will look like this. That's what y equals tan x looks like. So our amplitude is how high it goes, how high and how low. In this case, we could see this goes up to infinity, right? And it goes down to negative infinity. So there is no real amp because it goes up to infinity and down to infinity. There is an a value. The a value is 2, right? I have a b value here also. My b value is 1. My period in this case, very important, is pi over b. If I make a mistake during this lesson, that's where it's going to be. So it's going to be pi over 1, which is pi. So I said when you graph a trig function, you want to state the amplitude, the period. I like to label a and b. We draw a basic curve, and now we label it. So the period is at pi. So my period is here, right? That's the end of one cycle. So this will be pi. So I'm going to label that pi. And then how is this 2 going to affect things? Well, we want to find a point. We want to find what this point is. Well, if this is pi and this is half pi, then this is 1/4 pi, right? So I want to know y is equal to 2 tan, and for x, I'm going to put in 1/4 pi. And I know what tan of 1/4 pi is, right? It's tan of that 45-degree angle. This is always equal to 1. Tan of 45 degrees or tan of 1/4 pi is equal to 1. So I have y is equal to 2 times 1. So this value is going to be 2. So I have a convenient point here of 2. Well, if that's 2, then this is 2. And this would be negative 2. So I could find these points. If this is 1/4 pi, this is 2/4 pi, then this point is 3/4 pi, comma, negative 2. 4/4 pi, 5/4 pi. This is 5/4 pi, 2. 6/4 pi, 7/4 pi, negative 2. So this would be what the graph looks like. You could check it by substituting these values in. Should we try that? Let's try that, just for fun. I'm going to draw a unit circle. So I just want to check some points to make sure this makes sense in this equation. So 7/4 pi, if I put 7/4 pi in here, if I do y equals 2 tan 7/4 pi, well, I want to know what 7/4 pi, tan of 7/4 pi is. So let's look here. Well, I know this is 1/4 pi, and this is 2/4 pi, and 3/4 pi, and 4/4 pi. This is 5/4 pi, 6/4 pi. This is 7/4 pi. And what would the coordinates be of 7/4 pi? Well, it would be the same as these, right? This is rad 2 over 2. Reflected down here would be rad 2 over 2 negative rad 2 over 2. And tan is my y value over my x value, which would equal 1, but 1 is negative and 1 is positive. So this value would be negative 1. Tan of 7/4 pi is negative 1. So I have y is equal to 2 times negative 1, which will give me my negative 2, which is true. So if I plug in 7/4 pi, I get negative 2, and that's why. Right? And since we're doing increments of 1/4 pi, all of these are going to be rad 2 over 2. Right? This is going to be negative and positive. This is going to be negative and negative. Right? But every time we're using increments of 1/4 pi for tan, it's always going to come out to 1. So it's pretty easy to check. So here we have y equals tan x again, and y equals negative tan x. Right? The negation of the function always reflects about the x-axis. So what once turned up in a positive direction now reflects and turns down. Right? So each one of these have changed and reflected about the x-axis. So y equals negative tan x. It looks like this graph. So now you kind of have 6 graphs. You have sine, cosine, and tangent, and then you also have the negation of each one of those reflecting over the x-axis. So just like prior, we have phase shifts with tan. This has a phase shift of, oh, what is a phase shift? Let's do our setup here with our amp and all that stuff. Right, let's throw in our amp here. Well, in here in tan, there is no amp. Right, we could say NA. My period is pi over B. So in this case, my period, my B is over here. Maybe we should label our A, B, and our C. A is 1, B is 1, C is pi over 2, and D is 0. So my B is pi over B, which would be pi over 1, which is pi. My phase shift is negative C over B. So it's negative pi over 2 over 1. So it's negative pi over 2. So it means everything is just going to shift to the left 1/2 pi. And since I already have the graph up here, let's take a look at the graph. This is y equals tan x, right? So this is pi, and this is 1/2 pi, and this is 1.5 pi. So if everything is shifting 1/2 pi to the left, right? Well, now this point is going to be over here. What also shifts are asymptotes. So my asymptote is now going to be over here. Right? So this graph, once again, we could do it visually by moving everything over, or we could subtract 1/2 from all of our x values. But we see it's a pretty easy graph maybe to visualize. All right? If my If my asymptote was once here, now it's going to be here. So my asymptote is now here. And let's put our points pi, 2 pi. This is half pi, and this is negative half pi. So everything moved over half, so now this is going to look like that, right? And then I'm going to have this there, and I'm going to have an asymptote at pi. It was once at 3/2 pi or pi and a half. It's going to move over half a pi. And now this will be here. And actually, I'm going to have an asymptote here. But this we don't have to show. So in this case, we shifted everything to the left 1/2 pi. And we also showed 2 periods, right? That's 1 period. And this is the second period. Sometimes in the book, it asks for you to show 2 periods. When we normally graph y equals tan x, we're graphing 2 periods, 1 period here and 1 period there. So everything just shifted. 0 is here. This is my y-axis. This is my x-axis. Easy enough to do. This is the same exact problem. The same exact problem, except for it's negative tan. So we're going to be using this graph. And pi is here, and half pi is here. And 0 is here, and this is 3/2 pi. So everything is moving over 1/2 pi. So I'm going to be at negative half pi, 0, half pi, pi, 3/2 pi. Right? And the same thing, my asymptote moved over half a pi. So it once was at 1.5 pi, now it's at pi. What once was at 0 is now here at negative half pi. So my new graph looks like that. I took my old graph here, and everything shifted 1/2 pi. Label axes, and that's it. Everything you ever want to know about graphing tan. In the textbook, they don't give you any vertical shifts with tan, plus D here. But you could have a vertical shift, right? If it said +1, everything would just be up 1, right? It would just be all up here, just like moving the axis up. I'm not going to do that because the book doesn't do that, but it's easy enough to do.
Professor?